Question 15 from Section 1 of the 2017 Higher Physics Examination from the SQA. A point source of light is 8 metres away from a surface. The irradiance due to the point source at the surface is 50.0 milliwatts per metre squared, and the point source is now moved to a distance of 12 metres from the surface. The irradiance due to the point source at the surface is now, and we're given our usual 5 possible answers. Well, let's have a mental picture of what's happening. We have the source of light 8 metres above the surface, and the radiance at the surface is 50.0 milliwatts per metre squared. We're now going to move the point source up to 12 metres, and we're going to work out the irradiance at that position. Well, we go to our higher physics sheets, our relationship sheet, and we have two equations dealing with irradiance, and it's the top one we use because irradiance in the top one is equal to a constant K divided by d squared, and so we're dealing with irradiance and distance, then it's obviously the top one we're going to use. So let's get it in the form ready to do the problem. We know for a fact that the radiance I is going to be equal to a constant divided by d squared. Now if we cross multiply, we're going to have I d squared is going to equal to a constant number. Now that means no matter what value of irradiance and no matter what value of distance you have, if you multiply the irradiance by the distance squared, you'll always get the same number. So therefore we can write down the following. We can say the first irradiance, I1, times the first distance squared should equal the second irradiance value times the second distance d2 squared. That's our condition. Now we can plug in the numbers from our little diagram. We can see that I1 is going to be 50. We'll just leave out units for now, 50. Multiplied by d1 squared, it's going to be 8 squared. So that's going to be the first part of our equation. And over here we're going to have I2 multiplied by distance 2 squared, which is going to be 12 squared. To find I2, we must divide both sides by 12 squared. So our actual sum becomes 50 times 8 all squared. I'm going to divide that by 12 all squared. And that's going to give us a value for I2. If we do that in our calculator, we end up with a value of 22.2 and the units which we've kept out, milliwatts per metre squared. So that's our radiance when we move the point source to a distance of 12 metres from the surface. And the answer is going to be A for this one. Question 16 from Section 1 of the 2017 Higher Physics Examination from the SQA. The output from an AC power supply is connected to an oscilloscope. The trace seen on the oscilloscope screen is shown below. And the Y gain setting on the oscilloscope is set at 1.0 volts per division. The RMS voltage of the power supply is, and we're given 5 possible responses. Now the Y gain setting means that each block, each division in the Y direction is going to stand for 1.0 volts. Now we can draw in the centre line. If I can bring this out here, there's the centre line of the oscilloscope along there, and we can see that the peak voltage is actually 3 boxes up or 3 divisions up, and we know that one division stands for 1 volt in the Y gain, the Y axis, if you can think of that. Let's go to our higher physics relationship sheets, and you can see we have the V peak, the peak voltage is actually the root 2 times V. So we can see from the diagram we have got a peak voltage of in fact 3 volts. So our peak voltage, V peak, is going to equal to 3 volts. And we're going to be after V RMS, the root mean squared value of that, which is a kind of average. So we select the equation V peak is equal to, or it's VP, V peak equals the square root of 2 times V RMS. And then we take the peak voltage and divide it by the square root of 2, we'll get this V RMS voltage. Let's plug in the numbers. The peak is going to be 3 volts, and we divide that by the square root of 2, and if we do that on our calculator, we end up with a value of 2.1 volts, and just always tell it's VRMS. So that's going to give us the answer to 16A. So our answer is going to be 16A. Question 17 from section 1 of the 2017 Higher Physics Examination from the SQA. A 20 microfarad capacitor is connected to a 12 volt DC supply. The maximum charge stored in the capacitor is, and we're given our 5 possible answers. So we're dealing with a capacitor, we're dealing with its value, 20 microfarads, and a voltage across the capacitor, 12 volts DC. Go to your relationship sheet and you can pick up the section of it which is to deal with capacitors. And you can see we've got the top equation is the one we're going to use because it's got capacitance, it's got the charge Q, and it's got the voltage V. So let's work out the equation we're going to use them. So we have capacitance C is going to equal to the charge divided by the V. We're after the actual capacitance of the capacitor, and therefore we're trying to find the charge stored on it. So cross multiplying, we're going to have the following, put that over 1. We're going to have Q is going to equal to CV. So we're going to take the value of the capacitor, multiply it by the voltage, and we'll have the charge stored on it. So let's put in the answers in. C is going to be 20 microfarads, so it's going to be 20. A microfarad is times 10 to the minus 6, so we've got 20 times 10 to the minus 6, multiplied by the voltage, 12 volts there. So Q measured in coulombs will give you an answer of 2.4 if you do it in your calculator. 2.4 times 10, and it's going to be times 10 to minus 4. And remember, it's coulombs for charge. So our answer for question 17 looks like it's going to be answer B. 2.4 times 10 to minus 4 coulombs.